Okay. Now, one more important thing. So, image is formed here. So, what will be the size of the image over here? What will be the size of the image? In order to understand or in order to measure the size of the image, what we will do is, we will be measuring from the principal axis. From the principal axis, we will be measuring it. Okay, we will be measuring from the principal axis. So, if the object is, and here what we will understand is, it will be an inverted image formed. That means a small, the big huge candle or huge tree which was kept, or any huge object which was kept at infinity, will be getting a small image, So, if we measure it from the principal axis, it will be inverted also. Inverted in the sense, if we have kept an image like this, object like this, if the object is in the upside down, in the upright position, the image will be upside down. Okay, so that means the image will be like this, hanging down. It will be hanging down like this. That means we will get the image in the upright, means what, in the opposite position of the object. Okay, and how to get this image? We will understand that it will be intersecting at this point. So, the intersection itself we can't see it. So, in order to see the image, that means really it is meeting, isn't it? Both these reflected rays are meeting really. Both the reflected rays are intersecting really. So, real image is formed over here. Real image is formed, and I have told you it will be inverted. In the next case, you will understand it more clearly how it is inverted, why it is inverted. Okay, so it will be inverted. Okay, so real image, I hope no one is having any doubt, because really both the rays are meeting. So, you will understand it when the case when we are discussing virtual image, or the image is formed, not a real image is not formed, there we will say it is a virtual image. So, when we are discussing that case, you will understand what what's the difference between real image formation and virtual image formation. Okay, so here really the reflected rays are meeting, and it will be inverted, and it will be smaller size. So, in order to measure the size of the object, what we have to do is, we have to take a scale and we have to measure it from the principal axis. Clear? Okay, so it is inverted and point sized image. Point sized image, or highly diminished image. Highly diminished. Diminished means what? Diminished means what? Diminished means smaller. Okay, so highly diminished image is formed. And what I was discussing, how to get this image? The intersection will form the image, but we can't see it. In order for us to understand, or in order for us to visualize the image, what we have to do is, we have to take a screen, a white background, a small white background cardboard. You take it, and what you have to do is, keep it near to the mirror, and you just adjust the length from the pole in such a way that you will be able to get a clear image. If you keep the object here, and in between you just adjust the screen in such a way that you are going to get a clear image of the tree. You will get a clear image, not a vague image. It will be a clear image, highly precise image you will get, and in that image, on the screen you will get, for example, if you are keeping it like this, if the candle is kept over here, okay, you are keeping the candle here, okay, and let this be the concave mirror. So, this is not this much big, but you understand it. This be the concave mirror, the candle is kept over here, okay, or the candle is kept over here, okay. So, what you will do is, the rays from the candle is coming and hitting. This is not this much big, but in order to understand, I am explaining it. So, and the rays are coming and it will be intersecting at somewhere over here. So, what I have to do is, I have to take a white background screen and I have to adjust it from here in such a way that I am able to get the image of this candle or the object on the screen. Okay. So, at that position, if I get a distant object, the position at which the distant object is got or obtained from the pole, I have to measure the distance till the screen is kept. So, if I measure the distance till the screen is kept, what will be that distance called then? In this case, what will be that distance called? That will be, the distance will be called as focal length. Distance will be called as focal length. Okay, so there is no doubt in this, because we have the theoretical value that the theory says that whenever an object is at infinity, only parallel rays will come, and those parallel rays will only intersect at focus. Okay, so practically if we adjust a screen from the mirror, and if we get a distant object, the distance between that screen and the mirror will give you what? The focal length. Okay, so this is how you have to understand. You have to find out the focal length of any mirror given. If you are given any mirror, what you have to do? You just focus a distant object, a tree, at a distant place. Means what? At a distant measurement. Okay, so what you will do? You will focus that tree on the mirror, and you will adjust a screen, and wherever you are getting the image of that distant tree on the screen, that distance between the screen and the pole or screen and the mirror, that will give you what? The focal length. Clear? Okay, so if you get the focal length, then it's very easy to find out the center of curvature of that mirror. How to find it out? You just calculate. Focal length will be always the half of the center of curvature, or center of curvature C. Center of curvature C will be what? 2 times, not center of curvature, the radius of curvature. The distance will be called as the radius of curvature, isn't it? So the radius of curvature R will be 2 times the focal length, isn't it? Okay, so if you understand the length of the focal length using this mirror and the screen, you can find out the center of curvature of the lens, of the mirror. Okay, so the first case, it is if the object is at infinity, the image will be formed at focus, and that image can be understood with the help of a screen, isn't it? And if the screen is kept at a distant object is, or clear image is formed on the screen, that distance we can measure, and we will understand the distance of the focus. At what distance, or where is the focus located? And if we get where is the focus located, what we can do? We can calculate the radius of curvature, and we can find out the point, center of curvature, isn't it? So that is it. Now the second case, what I am doing is, now we have found out the center of curvature of any mirror. If any mirror is given, you can find the center of curvature like this. So now what I will do is, I will take the mirror, I will keep a measuring scale in such a way that I will understand where the focus is. If the image is formed here, I will understand where the focus is. So the double distance I will take, and I will measure the center of curvature. Means what? I will mark the center of curvature in a table. So if I keep the screen over, means what, the mirror over here, I will measure it, I will mark the principal focus here, center of curvature here. Then what I will do is, the object I will keep it near to the center of curvature. Here, if this is the center of curvature on the table, I will keep the candle or the object like this in the upright position itself. So always the length we can, whatever the length of the object can be measured from this will be the length of the object kept from the principal focus. Okay, so now if it is near, so now what I will do is, I will keep it near to the mirror. Second case, beyond C, beyond the center of curvature, or near to center of curvature. Okay, so it will be, we will keep the object near to the center of curvature. So we will have the concave mirror, pole is over here. Pole is over here. Okay, this is focus, this is center of curvature. I will be keeping the object, any object, let it be any object, I will be keeping it near to the center of curvature. I will keep it near to the center of curvature. Okay, so here if we can't take all in a parallel rays, because it is near to the mirror, so any rays can come through this, Okay, it can be through the center of curvature, it can be through the principal focus, it can be through the pole. Okay, and it can also be parallel. So what we will do is we will take any two rays, we can take it any two rays. So I will be discussing here with two types of rays. You can find out using other types of rays so that and find out where the image is formed, and you will understand that the fact that whichever rays we take, whichever type of rays we take, the image will be formed at a particular position only. Okay, so I will take one ray as parallel. One ray I am taking it parallel, so where it will move through the focus. The second ray I am taking the ray coming through the focus. Ray coming through the focus. It will be moving parallel to the. It will be moving parallel to the. Okay. So one important thing to be noted down is that the measurement should be correct. Whenever you are drawing the figure, the focus should be at equal, this distance from the pole should be equal to this distance from the focus. Then only you will get the correct image formation. Okay. So I am keeping an object here. I am keeping an object here. One ray will be parallel. A ray will be parallel. It will move through the focus. Another ray will be coming through the focus. It will move parallel to the principal axis. So where is the intersection? There are two sections of two places of intersection, but here is there any confusion for you? Will the image formed at this intersecting point? At this intersecting point will the image form? No, because the first ray is coming, this is the reflected ray, but what is happening here? This ray is the incident ray. This is the incident ray, isn't it? So a reflected ray and the incident ray won't form image. Only two reflected rays will form image. So where will be the image formed? This is the incident ray, this is the reflected ray, this is also another reflected ray. So the image will be formed over here. The image will be formed over here. Okay, the image will be formed over here. So listen here. Now you will understand the why I have told it is inverted. Okay, here also will the image be real? Will the image be real? Really both the reflected rays are meeting. So where is the image formed? That's the first question. Where is the image formed? The image is formed between center of curvature and focus. You know how to find out where is the center of curvature, where is the focus, you will understand. So in between distance, the image will be formed. Object is beyond C, image between center of curvature and focus. The image is between the center of curvature and focus. Okay, and is the image real? It is real because both the intersecting rays are originally meeting, isn't it? Okay, so it is real image, and I will tell that the image is inverted. Why? If I have kept the candle like this over here, if I have kept the candle like this, what I will understand is the candle which I get over here will be like this. When I adjust the screen like this, at this position if I keep, I will get a clear image of the candle but in the upside down position. To understand this clearly, you take out your spoon which we use at our kitchen in order to stir the coffee, etc. So you keep the spoon in front of our face and you adjust it like this. Means what? At different positions you keep it. You will see your face. It should be a clear shining spoon. You will see your face in the upside down position at some positions. When you keep it closer, you will see it in the same position. Okay, so you will understand it like the inverted image. Your face is upside but it is inverted. Okay, so likewise it will be the screen. On the screen you will get the image of the object in the upright, means what, downside position, inverted position. So the image is inverted. the image is inverted. Okay, now the size with respect to the object size. The object was like this much length, but here the image is smaller than the object. The image obtained on the screen is smaller than the object. That means when I measure it from the principal axis downwards, this distance will be lesser than this distance. This distance will be more than this distance. So the object is having longer distance, or the object is having longer height than the image in this case. In the before case it was highly diminished. This here somewhat bigger image is formed. Okay, so here it is diminished image. Here it is diminished image. Clear? Okay, so here real, inverted and diminished image is formed when the object is kept beyond C. Okay. Now one more important thing to be noted down. If I am keeping an object near to C, I have to calculate the distance of the object from the pole. Whatever distances we are calculating, we will be calculating it from the pole. Okay, so what I have to do, I have to calculate the measurement, I have to take the measurement from the pole. Okay, from the pole or from the mirror. If I am distance is measured from the mirror to the object, that distance is called object distance. If I am calculating the distance of the object from the pole, that distance is called object distance, and we will be denoting it by the letter small u. So object distance means the distance of the object kept from the mirror. Okay, so from the mirror we have to calculate the distance, or we have to measure the distance, and we have to note it down, so that that distance is the object distance, and we will denote it by the letter u. And what will be this distance from the object, or we are keeping the screen near to the mirror, adjust the screen and we will get a distant or clear object, clear image. So the distance from the screen, or the distance from the position at which the image is formed to the pole, what is that called? That is called image distance. That is called image distance. That is called image distance. Okay, and we will be denoting it by the letter V, small v. We will be denoting it by the letter small v. So we will be denoting it by the letter small v. Okay, so these object distance and image distance should be there in your mind, so that we will be having a lot of calculations to be done. Okay, the object distance, the image distance, the focal length, these are very important. The object distance, the image distance and the focal length are very important for a calculation in this chapter. Okay, so the second case, the object is kept some more nearer to the mirror, that means near to C, is near to the center of curvature. If we keep, what will happen? What will happen? The image will be formed between C and F. Image will be formed between C and F, and the image is real, inverted. It will be below the principal axis. That means it will be in the upside down position. So we have to measure the size from the principal axis to downwards. The object always will be keeping it in the upright position. Above the principal axis only we will keep the object. Okay, so if we always will keep it in the straight position, so at some positions we will get the image in the upright down position. Okay, and in some cases we will get it in the straight position itself. Then we will say that it is erect image. Same side it will be, the image and the object will be in the same side. So it will be, we will say the image as erect, but here it is inverted and it is diminished. With respect to the object, what is the size of the image? It is smaller. So we will say it is diminished. Okay,